So any last questions on the ellipse? If you have any last questions, now is the time to bring it up, because otherwise we're moving on to the hyperbola. So how many problems were there on the ellipse worksheet? There's 7. So out of these 7, there's going to be 3. 8. This. Oh, 8. Okay, so there's going to be 3. And you're going to need your graphing calculator tomorrow. So I wonder which one.
They're conic.
They're all conic.
I mean,
They're all conic.
7. Where it's like I did like that.
So no questions. Yeah, because we did them all last time. So are we all caught up? Yeah, right. Okay, now we move on to the hyperbola. Now what was the definition of an ellipse? It's the set of points in a plane such that the sum of its distances from 2 fixed points is constant. So here are the 2 fixed points. These are the foci. So if this is a representative point, x, y, then this distance plus that distance is constant, right? But for a hyperbola, do you guys even remember from last year? It's the difference of the distances is constant. So why don't we call this point P? So in an ellipse, the distance from P to F1 plus P to F2 is constant. And what do we call it constant? You guys told me last week. 2A. Where is K? There's no K. 2A. The constant in the ellipse and the hyperbola, the constant is always 2A. In fact, if you don't know that, how can you do number 1 on the ellipse worksheet? If you don't know the constant is 2A. Okay, but in a hyperbola, the difference of the distances between 2 fixed points is constant. So that's the only difference between the definitions. In ellipse, it's plus. In a hyperbola, minus. So you can expect a lot of the equations to be the same. In fact, they are, right? For a hyperbola, if it opens left and right, then it's x minus h squared over a squared minus y minus k squared over b squared equals 1. That's the standard equation of a hyperbola that opens left and right. If it opens up and down, then the y comes first. Y minus k squared over a squared minus x minus h squared over b squared equals 1. This hyperbola opens up and down. Now in an ellipse, a squared is always what? The larger denominator. That's because in an ellipse you have the major axis and the minor axis, right? One is bigger than the other. But in a hyperbola, a squared always goes with the positive term and b squared always goes with the negative term. So sometimes b is going to be bigger than a in a hyperbola. And in an ellipse, c squared equals... You gotta know this tomorrow, people. A squared minus b squared. But in a hyperbola, c squared equals a squared plus b squared. Whoa. Did you call me? This is, yeah, no name calling. Okay. Okay, I was gonna be nice to speak, but all bets are off now. So you can't even call your regular name. What do I call you then? Okay, I'm going to go to your textbook from last year, and we're going to pick out by random a hyperbola. What chapter was the parabolas? Oh, right there, hyperbola. 7.4. Okay. You did these problems last year. Okay, I'm going to erase this now because we're videoing. We only have so much room. Okay, let's pick one at random. Somewhere where we got to complete the square. How about what? Come on, people. Are you joking me? Okay, here we go. X squared minus 2y squared minus 2x minus 8y minus 3 equals 0. Okay, how do I know this is a hyperbola? Minus. If there's a minus, if A and B are opposite sides, it's going to be a hyperbola. Okay, now how do we put this into standard form? What do we need to do? You got to complete the square again. So you put the x terms together, leave a space. Now the y terms, look, factor out a -2 because that's the coefficient. What's going to be left? Y squared plus 4y, leave a space, throw the number on the other side. Okay, now what do I have to add here to make a perfect square? Take half of that and square it, 1. If you add 1 on this side, you got to add 1 on that side. What do I have to add here to make a perfect square? 4, but what did I actually add? No, -8. So you got to add -8 to both sides. So this becomes x minus 1 squared minus 2 times y plus 2 squared equals -4. Now, in order to make this standard form, this has to be 1. So what do I do? Add 5 to both sides. No, you divide by -4, which means this is going to become the positive term. So y plus 2 squared over 2 minus x minus 1 squared over... Oh, this is ugly. See, they make their numbers any kind. I can tell already this is ugly. But that's okay, we're going to go with it. So is this a left-right hyperbola or an up and down one? Up and. Now remember, where's the center? -2, 1, or 1, -2? 1, -2. Look, the x goes with the x and the y goes with the y. It's 1, -2, and then you make the box. How much do I go left and right? Okay, now this is a squared, this is b squared. How much do I go left and right? You look at under the x's. The x's tell you left and right, the y's tell you up and down. So you go 2 left and 2 right. So 1, 2 to the left, 1, 2 to the right. How much do I go up and down? Root 2, which is about 1.4. 1.4 up, 1.4 down, and then you make the box. Right? Then you draw in the asymptotes, and this is an up and down hyperbola, so it looks like this, and like that. Remember we did this last chapter in Polar? Oh my goodness. How do I know it goes up and down again? Because the y's come first. The y's are positive. If the x's come first, then it goes left and right. Okay, what are these 2 points called? The vertices. Okay, what are the vertices? Well, what did we do? How much did we go up and down? So if I go root 2 up, where are you going to be? 1 comma. -2 plus root 2. Oh gosh, see how ugly? Well, I'm not going to use this in the other classes. -2 minus root 2. What are, okay, and what do you call the segment that connects the 2 vertices? Do I call it the major axis? No, because it's smaller than the other one. How can it be major if it's smaller? So that's why in a hyperbola, we don't call it major and minor axis. We call it the, this is called the, it's in the notes. This is called the blank axis. The transverse axis. This is called the conjugate axis. And what are the endpoints of the conjugate axis called? The endpoints of the conjugate axis. Okay? So what are the endpoints of the conjugate axis? Well, you went 2 left and 2 right. So if I go 2 left, where are you? -1, -2, see? And then if you go 2 to the right, you're at 3, -2. Okay, so that's the stuff you did last year, right? In fact, last year, didn't you even find the foci? I think you did. Okay, now here are the 2 foci. How do I get to the 2 foci? The distance from the center to the focus is c. C squared is equal to a squared plus b squared, which is equal to 2 plus 4, which is 6, which means c is radical 6. This is terrible. So if I go radical 6 up, where am I? 1 comma, -2 plus root 6. Horrible. And if I go down radical 6, you're at 1 comma, -2 minus radical 6. And just like the ellipse, if you have a focus, that means you have to have a directrix on the opposite side of the conic. So you're going to have one directrix here and one directrix there. What was the distance from the center to the directrix in the ellipse? You better know this tomorrow.
2b squared.
No, a squared over c. I told you guys could be smart. So what is a squared? Look, you're pointing at it. 2. What is c? Root 6. That's horrible numbers. So to get from the center to the directrix, you have to go 2 over root 6 up. Maybe we should simplify that, because that's ugly. Yeah? 2 root 6 over 6, which is root 6 over 3. This is ugly. Okay, so if I'm at -2, and then I go root 6 over 3 up, where am I? So the equation of this is y equal -2 plus root 6 over 3. And then if I go down, you're going to be y equal -2 minus root 6 over 3. Those are the two directrices. What was the eccentricity of an ellipse? C over A. Is that the same? And it's the same thing for the hyperbola. And you can expect a lot of the things to be the same because the definitions are almost alike. So what is C? And what is A? Root 2, so that simplifies to root 3. So the eccentricity, again, is just a number that tells you the shape of the hyperbola. Now you can see that C over A in a hyperbola, look at this equation. What's the biggest of the three, A, B, or C? C. So if C is always bigger than A, the eccentricity is always going to be bigger than 1. So like I told you last week, if the eccentricity is 1, that means it's a parabola. If it's less than 1, ellipse. Greater than 1, hyperbola. And that's how you tell what kind of conic section it is. You look at the eccentricity. And the eccentricity tells you the shape. So if the eccentricity is close to 1, then what does the hyperbola look like? That means the focus is going to be very close to the vertex. Is it going to be really wide?
Narrow.
Is it going to be really wide like this? Or is it going to be like that if the eccentricity is close to 1? You know what? I'm not going to tell you. You're going to figure it out. Maybe that might be a question on the test. And if the eccentricity is like really big, like what if the eccentricity is 100? Does it look more like that or more like that? Then look, if the eccentricity is really big, then the focus would be like really far away. I still don't know. Okay, well, I'm not going to tell you. What is the length of the latus rectum in an ellipse? Here's the latus rectum right there. Get 2 latera recta.
2b squared over
2b squared over A. You're going to know this tomorrow. Okay, so for this hyperbola, 2 times, what is b squared? 4 all over A, which is root 2. Yikes! 8 over root 2, which simplifies to 4 root 2. So the length of this latus rectum is 4 root 2, and so is that one. Okay, so that would be all the same things as an ellipse, except a hyperbola has 2 things an ellipse doesn't have. Asymptotes. Come on, you guys did this last year. Here are the 2 asymptotes. Write the equation of the 2 asymptotes. Now the 2 asymptotes always intersect where? At the center. Now, when you write an equation of a line, you need a point, you need slope. So we know it passes through the center. What about the slope? What did we learn last year? If the hyperbola is a left-right hyperbola, then the slope is
b over
plus or minus b over a. But if it's an up-down hyperbola, then the slopes are plus or minus a over b. Does this even sound familiar? And you don't even need to know that. You know why? Just look at the box you drew. Okay, what is this? Was this A or B? That was B. And what was that when you drew the box? That was A. So is it rise over run, A over B? So you really don't need to memorize. You can just figure it out, but you can't because you don't even know what you're doing. So in this problem, since this is an up-down hyperbola, then this is the slope of the asymptotes. So in this case, what is A? Root 2. What is B? 2. So the slopes of the asymptotes are plus or minus root 2 over 2. Because look, right, didn't we go root 2? Isn't it 2? So rise over run, root 2 over 2. So what are the equations of the asymptotes? You use the slope and you use the center, just do point slope form. Y plus 2 equal plus or minus root 2 over 2 times x minus 1. Those are the equations of the two asymptotics. Okay, so this is the review from last year. I just basically showed you all the parts of the hyperbola. Okay, but now, I'm going to describe a hyperbola, and then you have to write the equation. That's the kind of homework you're going to get. Why would I give you stuff from Algebra 2? That's baby food. Okay, why do we study hyperbolas? Just so teachers have jobs? No, because they have reflective properties. Now, I already showed you the reflective properties of the parabola and the ellipse, right? If you have a hyperbola, here are the two foci. If you have a light, let's say a laser, you aim it at one focus. If it's going toward that focus, it's going to bounce off the hyperbola. Where do you think it's going to go? To the other focus. That's the reflective property of a hyperbola. So, knowing this, we can make a telescope. You guys ever heard of a telescope? Okay, how many of you went to Iolani in lower school? That's it? Did you guys have astronomy night?
Sixth grade?
Sixth grade.
Sixth grade.
Oh.
Sixth grade. Six.
Whatever. Isn't 6 lower school?
Yeah.
Yeah.
Astronomy was fourth grade.
What do you mean you didn't do astronomy? Yes, every year they do astronomy night.
What was Space in fourth grade?
Only grade before.
I don't know what grade it is.
He's in first grade.
But when you went there, didn't they set up all these telescopes? Or you're just running around like maniacs, eating more candy than you're supposed to. I don't remember the telescope. Oh gosh. Anyway, the kinds of telescopes they set up out there, these were called Cassegrain telescopes. Okay, and Cassegrain telescopes work on the principles that you have a parabolic mirror and then a hyperbolic mirror. Okay, so you aim the telescope at the heavens, right? And then all the light is coming into this telescope. Okay, so the light comes in. Okay, now what we want to do is we want to focus all the light to one point. So what do you think is going to happen? We need a parabolic mirror. So inside here, you have as big a parabolic mirror as you can. That's why the wider it is, then the bigger the mirror can be, right? So all the light coming in, it hits this parabolic mirror, and then it bounces off and goes to the focus. So all the light gets concentrated to the focus. But what's the problem with that? Yeah, how you can see inside the thing. You can put your head inside and then block out the light. You can't see anything. So we need to somehow reflect the light there to an eyepiece somewhere on the outside. So where do you want the eyepiece to be? Like over here somewhere?
It's on the side of the mirror.
Where was it? Over here. Where was it? On the side in the middle. The eyepiece was here.
Well, that's what my telescope looks like.
Okay. See, I don't know. I don't remember where it was. I was just running around like a mad person. I ate too much candy. Okay, so what you do now is that now you have a tiny hyperbolic mirror. A tiny one now. Why does it have to be tiny? Because otherwise it's going to block the light. But now you have a hyperbolic mirror, so all the light that goes here bounces off this tiny hyperbolic mirror and goes to the other focus. So you place the eyepiece where the focus of the hyperbola is going to be. So it's going to bounce off and then all the light gets focused over there, and then you can see it. And that's how a Cassegrain telescope. So that's why we study conic sections, people. Okay, let's do one example. Or shall we do two? Okay, what kind of problems do you have on tonight's homework? Let me look. Well, I'll do, okay, let's do a polar one. R equal, I don't want to make it the same as tonight's homework. 3 minus 4 Sine theta, look at tonight's homework, the polar one, does it look like that?
No.
Has different numbers of these?
Different
Okay,
numbers.
good. Now I'm trying to make it come on nice. Shh. 1, no. 3, 1, and 7, 21 then. There you go.
How did you do
Because I know how it works, that's why. First of all, how do I know this is a hyperbola? No, no,
that? I think
it's polar. Remember I told you last week, when you see r equal EP over 1 plus or minus e sine theta or cosine theta, this is a hyperbola. I mean a conic section. And how do you tell what kind of conic section it is? You look at E. E stands for eccentricity. What is the eccentricity of this? And you better not say 4.
change it to 1.
It's 4/3. You have to make this number a 1, which means you have to multiply top and bottom by 1/3. This becomes 4/3. And if the eccentricity is 4/3, since it's greater than 1, it's a hyperbola. Plus we're studying hyperbolas, so it's hyperbola. Okay, now what was the way to graph the conic section? What did I tell you? Plot the 4 quadrantal angles. Okay, 0.
7.
7. 1, 2, 3, 4, 5, 6, 7. Pi over 2. Uh-oh.
-21.
Negative 21. So you got to go 21 units in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Pi. 7. So you got to go 7 units in that direction. Now 1, 2, 3, 4, 5, 6, 7. So that would be negative 7, yeah? Because we're rectangular. And then 3 pi over 2. 3. So 1, 2, 3. You got to go 3 units in that direction now. Now, do you see the placement of the 3 points? I mean, the 4 points?
What is this one?
1, 2, 3, 4. Do you see the hyperbola? It's right here. It's right down yonder. Oh. See, if this point was up here, then you would have the ellipse. But it's not, it's in there, that's why it's a hyperbola. Anyway, how do you draw an ellipse that goes through those 4 points? I'll give you a nickel if you can draw an ellipse that goes through those 4 points. And if one of these points is gone, like the down is gone, then it's going to be a parabola. If one of them was undefined, remember? So if you just plot the 4 quadrantal angles, and anyway, now what was the secret? What's the secret?
Focus at
This is the focus. The origin is always one of the foci. So here's one focus. Therefore, the other one has to be where? Remember, this was negative 21, right? So you have to go 3 that way. You got to go 3 this way. 1, 2, 3. So where's the other focus? So what? 0, negative 24. So therefore, where's the center? 0, negative 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the center at 0, negative 12. Okay. Find the directrices of this hyperbola. What are the directrices? What is the distance from the center to the directrix again? A squared over C. Do I know these things? Yeah, because A is the distance from the center to the vertex. How far is it from negative 12 to negative 3?
9. No.
Yeah, 9. So what is 9 squared? 81. C is the distance from the center to the focus. 12. 81 over 12 can be reduced to 27/4, which is equal to 6.75, correct? I just like changing to decimals once in a while. So to get to the directrices from the center, you just go 6.75 up, 6.75 down, and that's your 2 directrices. See how easy this is? But you gotta know, see, A squared over C, 2B squared over A, C over A. Is that hard to remember? I'm just gonna warn you, every year students put C squared over A. Every single year, there's always 5 or 6. Do not be that person. And last year, I even wrote the formulas on the top of the page, and they still put C squared over A. Who's that gonna be this year? Bart? That's it. You guys know that you guys are juniors. What happens, you know what I have to do at the end of the year? I have to write junior evaluations. Did Mr. Fleming tell you about that?
Yeah.
Okay, next year you guys are going to be seniors. You're going to be applying to college. Okay? When you apply to college, the school has to write a letter of recommendation from the school. Plus, you also have to get letters of recommendation from your teachers. Okay? Now, how does the school write your letter of recommendation? All your junior teachers, including me, they're going to have to write something at the end of this year, and they hire people to like combine them all together and write a letter from the school. So like the first question they ask us, what are the first words that come to mind when describing the student? So for Park, the first words that come to mind, Z, 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 right there. That's what I'm going to write. Because I just see you sleeping. But that's what I remember in my head. Like, what do you think Morris is going to get?
He's not even present.
Outstanding attendance, but no, he's not here today. You can't even get that. Okay, that's enough examples, I think. So does everybody understand what's happening this week? Tomorrow is the quiz on ellipses. So out of those 8 problems, you're going to have 3. One of them you have to use a graphing calculator, so duh, I wonder which one that is. And then the test is on Friday. Oh, I pity period 4 this week, yeah, because they're going to take the test at the end of the day on Friday. Are you guys really super tired on Friday, the last class of the day? No, you're wide awake. It's like now. Okay. No. I want you guys to cram on this chapter because you know what? It'll be easy to correct. Now, on this test, there's only 7 problems, so they're going to be 10 points each. So you blow 1 problem, it's minus 10. Huh? It is for this chapter. Because last year the average was low 70s. And there was no curve.
You don't do the beast curve?
I don't curve anymore in the second semester. Because you guys are used to me already. You know the difficulty of the class. You don't need those stinking curves. What about dropping? You can't drop already. Okay, the bell's gonna ring in 8 minutes. Use your time wisely.
Physics princess.
I'm serious. If you try to cram this semester, you're just gonna be crying.